So once we have that initial access to the OT network, then what do we do? Right? How do we put ourselves in a position to reverse engineer the process? Right? How we monitor and control the equipment in the environment, and ultimately to put ourselves in a position to where we can impact that process, that equipment. That's what we're going to talk about getting started with in this part of the course, as well as the next part. There's so much when we talk about discovery and collection is that first real phase of what do we do once we get that initial foothold in the OT network. So let's jump in. So when I'm sitting here looking at this slide, I'm reminded that this is probably one of my favorite sections of the entire course. And you'll see that probably because it's also the longest section in the course. But where we're talking about whether it's titled discovering and enumerating, or we talk about discovery and collection of understanding what OT assets we have in the environment, and not only what we have, but how they're related. And most importantly, what they're monitoring in the real world, right, how they're controlling that equipment and the processes out in the real world, and then ultimately using that information to understand how we can make changes, right? How we can manipulate those assets to then in turn manipulate that equipment to manipulate the process of what's happening in the real world. So we are talking about discovery and collection in this part of the course. And we'll spend some time in both. So let's jump in. When we're looking at this from the OT pen test methodology perspective, right, where I try to simplify the approach, that I have discovery and collection essentially as lumped into one stage, right? So this is where you can see we've performed our reconnaissance and we've gained initial access onto the OT network. Now, typically, right, for this course, we talk about once we have that initial access in OT, we're going to assume that you can have complete control over all the Windows-based assets in the OT network fairly quickly, right? Full control of Active Directory and everything that falls underneath it, right? Data historians, file servers, engineering workstations, operator workstations, right? The list goes on and on. So we start at this point of, well, what's next? So we have that foothold on the OT network. We have control over all the Windows-based systems, at least the ones that fall under Active Directory. Now we actually want to start looking for, well, what actual OT or ICS assets are in the environment? What PLCs exist, right? Is there a DCS? Are there data historians? What HMIs are out there? Right? We're starting to find out what pieces of equipment are out there, right? As far as OT assets and basic information like, okay, here's an IP address, here's a MAC address. But then we also have to find out more information. This is where we get into the collection part to understand, well, how are those assets connected together? What are the relationships? I see an HMI over here. I see a PLC over here. Are they connected? Does that HMI monitor and control that PLC, or are they completely unrelated? We need to understand before we can get to eventually that point where we can have an impact in the environment. And so that's why, to me, discovery and collection is one of the most, if really not the most important steps in the OT pen test methodology. And so that's where, again, we're going to spend our time in this part looking at, remember, discovery, again, is finding at a high level, right, what's in the environment. And this is where we're focusing on OT and ICS assets like PLCs and HMIs, and there's a DCS there. Now we're going to talk about how we can find those different assets using either passive or active means. Remember, when we start talking about active, that's going to be between you and your client. I can't suggest anybody uses active means, right, to find hosts on the network. That's where we're generating packets, putting them on the network using tools like packet scanners like Nmap. Nmap is a great packet scanner. It's incredible, but at the same time, it could potentially cause safety or availability issues. So again, that's between you and your client. I can never suggest you use it in production. You can use it in tests environments and in labs, but I can never suggest you use it in production. Now, we are going to spend some time looking at some of those Windows-based or maybe sometimes Linux-based assets like engineering workstations, which, as you can see, we talk about, it's a treasure trove of information that we could use as an attacker or as a penetration tester to understand more about the environment, to understand about the OT assets that do exist and how they are related and how they monitor, and more important, how they control, right? How are they programmed to control this equipment, this process out in the real world that does something? So we can find a lot of that information on engineering workstations. So yeah, things like IP addresses and MAC addresses and maybe a text file with credentials written inside of it called, passwords.txt. I've seen it a million times. Right? I'm sure many others out there have as well. And then we talk about project files. That's any file like programming logic that is used to make up, right, our OT environment. I'll just say at this point. Now think about the data historians we've talked about previously as well, because the data historians, or they store all that telemetry data that's sent to it, or all of the OT assets like the PLCs, HMIs, right? They send that performance data, the telemetry, to the data historian, which stores it and then forwards it on. So we store that data, and we'll talk about, right, in forms of the different tags, or think of the labels we're going to assign the data. So if we see that 72, that we know, oh, okay, that's the temperature set point. So tags are important to find, to be able to understand, well, what is this data? Asset identifiers. You see different process variables. So the list goes on, right, of the information we can find in data historians, and that we can use it not only from a defensive perspective, and as operators use it to help find issues that's going on in the environment. Plus, we push that data to the business side of the house so they have the data that they need to do what they need, right? Like to understand how many vials of certain pharmaceutical we generated so they can coordinate shipping, logistics, storage. But we can also look at that data from a security perspective, not only again defensive, but offensive, again, to understand what's going on in the environment. How can we use that data to reverse engineer the process? And so we're going to have some examples, not only in this part of the course in the labs to work with, but also in later parts as well. And then we do mention a lot of these systems, right, when we talk about engineering workstations, right, data historians, they're all running on Windows. So they have all of those Windows vulnerabilities that make it really easy to take control over these assets and gain access to the data that's stored on them, especially if those assets aren't being patched on a regular cadence, or every once a month, even though they should be. Are we patching PLCs once a month in environments? No, of course not. Maybe not for years, if that at all. Any of our Windows-based assets that aren't being used for as OT assets, like an HMI running Windows, yeah, we should be patching those once a month. We need to be patching those data historians. We need to be patching those engineering workstations. We need to be patching those Active Directory domain controllers in OT. There's a lot to think about. Now, remember, that's discovery, just finding that there's these assets out there and things like IP addresses. But then we want to move into the collection phase, which is where we're finding out more information about each of those assets. And so if I want to start finding out more information, this is where we start thinking of things like, yeah, if I find HMI screenshots, or I have that GUI, that graphical interface that shows me the environment and what's being monitored, and potentially also has the ability to make changes to the environment. We talk about GIS data. This I thought was fascinating when this was highlighted when word of the Volt Typhoon attacks came out, because Volt Typhoon would get into the OT network or even in the IT environment where this data can reside. And one of the first pieces of data that they were looking for, that they wanted to steal, was the GIS data. Or when you talk about geographic information system, it's a fancy way of saying it's an application that we bring in information about the physical world in which that plant resides and the plant itself. So I come from the engineering and construction world. So I grew up, if you want, with a lot of GIS folks. And they would maintain GIS systems. Like we were a big ArcGIS GIS shop. That's one of the GIS products. And so when you're first building an environment, right, it would allow you to see, right, maybe the fields and where you're actually going to build, let's say, a power plant. And then allows you to map out, okay, what it's going to look like when we level those fields, right? We just make everything level. So this is where we're going to put the plant. And then you'll start showing where you're going to put in different roads and parking lots and where your internet service provider is going to come in. And see, in that power plant, the power plant's fueled by natural gas and water. So where are we going to bring in the natural gas? Where are we going to bring in the water? And then it allows you to then also detail out the plant itself, which could include the control systems. You can actually put in as much detail into these as you have time for and as you have long. We have one project where I got on with the lead for GIS for the company. And he showed me one example where you could zoom into this plant environment to see even like down to where one weld existed. And you could actually see even who welded that pipe and even the date and time and when they did it. That's how much data you can be, right? You can be very, very specific. So there's a lot of information you could think that an attacker could use in the GIS data to help understand the environment, how it's built, to use that to help reverse engineer the process. Now, we talk about PLC operating mode. I'm going to talk a lot about the PLC operating mode. It's actually really interesting because when we look at the MITRE attack for ICS framework, there's actually 3 main techniques that are used related to the operating mode. But think if I'm an attacker and I first get into an environment and I find a PLC, one of the things I want to find out is what operating mode is it in? Is it in run mode? Or maybe it's in remote program mode, because we talked previously about if a PLC is in run mode, we see that as read only, right? So an attacker couldn't upload malicious firmware, which is true. But a lot of people make the mistake to think, well, attackers couldn't upload programming changes to the logic on the PLC, and that's not true. Not with the majority of PLCs that are out there. So if I'm an attacker and I see, this PLC is in remote program mode, then not only could I make PLC programming or logic changes, but I could also upload new firmware. Or like the attackers in the Frosty Goop attack, they actually uploaded an older version of firmware to be able to downgrade the PLC, so it actually lost security monitoring features. And what if I just want to look at, well, when can I turn off a PLC? What if I drop it out of run mode? What if I put it in stop mode? So it stops operating and I can find just the right time in the process to have the biggest impact. So keep that in the back of your mind, because that's going to come up more than a few times. We're going to start looking at I/O values, right? What information do we have sitting in memory of our PLCs or other types of controllers? What about our safety systems? Again, we can use that information, especially if we line it up with other sources of data like HMI screenshots or data that we find in the historian, right? To be able to, again, understand how can we make changes to impact the process. And looking at the historians, right? Finding the tags. Remember the field names. If I know the field name, a lot of times that can tell me exactly what that value means. Unless the developer did a really poor job of naming them. Because sometimes you do see things like thingy 1 and thingy 2. Like, I have no idea what those do. But if you see pump underscore on, you probably know what that value is going to control. So we'll talk about those tags and the data points that we have in memory. And then we could have traffic sensitive information going over the wire. Remember, there's lots of different types of wireless traffic that we see in OT or ICS networks, because we have IT Wi-Fi, and we see that almost in just about every plant these days. But there's other types of wireless traffic as well. So it's like things like wireless HART for transmitting sensor data kind of over this like wireless mesh network back to a gateway to eventually get on the network. And we'll come back and talk more about it and some of the other wireless protocols later. But that's the idea of collection. Remember, we start with discovery of finding what's on the network and kind of where, right? Things like IP addresses and MAC addresses. But then we want to find out more information about those assets and how they're related. How do they work together to ultimately have this process that they monitor and control? So when you think, and we've already started to talk about some of these, but once you get into the OT network, where can we find more information about the OT or the ICS assets in the environment? Well, we can look for different things like configuration files, right? Well, the programming files themselves, right? So if I have that Siemens PLC, well, if I can find the appropriate file, right, that could actually show me, well, not only the logic, but I could use that to help reverse engineer how the environment works, how the process works. I think we've already started to get a really good understanding of once you find the HMI screen, remember it acts as that Rosetta Stone if you can line it up with a PLC or other type of controller that it's monitoring and controlling itself. To understand, okay, here's the information in memory sitting on, let's say, that PLC that we can manipulate to have an impact in the environment. Now, operators can have notes, whether that's in a notepad, maybe it's some type of application that they use. It's in different applications that can be homegrown or purchased. Like there are very specific, like if you go into a rail environment, there are very specific applications that you can purchase from well-known, rail operator providers. Or maybe, you build your own. Because if you don't have those certain reports, the trains don't run. Packet captures. I'm really surprised at how many OT environments I go in, and you actually find a lot of PCAPs, usually like generated with Wireshark or another tool, that just seem to be sitting around. I don't know. I don't know why it is. I find so many more readily available in OT environments than IT. I always find that just interesting. Remember, we mentioned engineering workstation data, right? Things like the programming files for PLCs. Maybe there's a bunch of even just having the versions of firmware available. Also think of the engineering workstation. You have the different applications from the different vendors of the equipment and the environment installed. So if you see Rockwell software installed, yeah, chances are there's some Rockwell equipment in the environment. If you see Siemens software, probably some Siemens equipment in the environment and the protocols that go with that. So you start to understand what you need to be looking for. So again, it's not discovery, it's not collection, it's discovery and collection. Because discovery, right? We go in and we find, oh, there's a PLC over here, there's an HMI over here, here's the IP addresses, here's the MAC addresses. But we have to go much further than that. This is where we start asking those questions. Well, what does the PLC monitor? What does it control? Which HMI is connected to this PLC? We start asking those questions. That's where we get to the point where we can reverse engineer the environment. We can reverse engineer the process. And that's where we can start identifying the risks, the vulnerabilities, right? The gaps in security. That's why the client's asking us to do the testing in the first place. Find the gaps in the security that could lead especially to safety or availability issues. Help identify those, work with them to understand what those issues are and then how to fix them, how to address them in the shortest time possible. But also help them to understand on their timeline when, if ever, they're going to address them. So how do we start to understand the process? Now, as pen testers, right, we have a little bit of an advantage because we can sit down with the client and we can do interviews. We can ask to talk with engineers and the plant manager and different folks that are responsible for operating the environment. We can talk to different folks from the business, right, to understand why does the environment exist in the first place. This is where I always ask as well as how much would you lose if the plant was down for an hour? You'd be amazed at how many people cannot answer that question in OT, especially in positions that they should be able to. They need to. Right? Why does this OT environment exist in the first place? Is it a power plant that's responsible for generating electricity for the public and also generating revenue for the owner? Is it a manufacturing plant that manufactures baseballs? Or is it a manufacturing plant that manufactures insulin injections, right? There's a big difference. Not saying, baseballs aren't important, but they're probably not as important as pharmaceuticals. Then we start to look at, well, what physical components, right? What equipment, right? What systems come together to make this process happen? So yeah, we can look at the OT ICS assets like the PLCs and the HMIs and the DCS, but what about the physical equipment out in the real world? That power plant has a turbine, right? That power plant has a generator. Power plant has a combustion chamber, right? All of these things come together to be able to generate electricity and a lot more, of course. Attackers don't have the ability to typically, right, sit down with the business unless they, pay a malicious insider or they call up and ask somebody that information over the phone in a phishing attack, and the person unknowingly just provides that information. And that can happen, believe it or not. But as pen testers, right, we need to we take the time, take advantage of the opportunity to better understand the environment and see it from the business perspective. Because if anything, it'll help you be able to set an appropriate tone and perspective you use when writing the report that will really, hit home for the client. If you can really prove that you understand their environment and how they see it. Then we start talking about mapping the network. And this is where a lot of times you talk about going into a client and doing things like a crown jewels assessment. Because when you think from a cybersecurity perspective, you might want to go into a plan and say, well, everything's important because if you lose part of it, then the plant goes down. And part of me says, yeah, that's right. But the other part says, you can't protect everything. We can try. But if we had to choose, and this is where we start prioritizing, what's absolutely right, mission critical to running that plant, like where would we start? And so we're going to come back and talk about that a little bit more in detail, like doing the crown jewel analysis and getting into a secure network architecture review. Now we can look at using those different PCAPs or other different types of sensors, right? Monitoring network traffic to understand what's out there. Though remember, this can be limited at times. It usually isn't going to give us a complete picture, but it can help for sure. We're going to look at the traffic that flows between or the different parts of an OT network and between OT and IT. And we want to look for the allowed traffic and any traffic that's blocked and make sure that, yeah, this is all expected. We don't want to see any traffic that we wouldn't want. So, of course, when I see block traffic as if something's going on, we're sending traffic that, well, it's not getting to where it's supposed to because we know it's being blocked. So is that legitimate traffic that's being blocked and we need to open up an access control list? Or is that an attacker in the environment? Or maybe it's more than likely a misconfigured service. But we need to find that out. So a big part of it, as pen testers, again, we can interview the business and start to ask them, right, how the environment is designed. A common question is, is a pen test in OT a white box where you get all the information, or is it a black box where you get none of the information, or is it a gray box where it's in between? If you're doing this, especially think in production, which again, I can never recommend anybody does, but if you're doing a full pen test in production that your client has agreed to, you want as much information as possible because that reduces the chance of any safety or operational availability issues. But we'll definitely be talking more about that. Again, the nice thing as pen testers is we have the ability to talk with the business. Treat it as a white box, right? I want all of the information. Yeah, I love doing black box. It's so fun and exciting to go into a new environment not knowing anything. And it's like, don't tell me anything. I want to find it all out on my own. That is probably some of the most fun you can have. So when we talk about what's right for the client, let's sit down and let's have a conversation. You can explain to me about the environment, what's in the environment, help me understand how to do the pen test more effectively, right? To find the risk that you don't see, that we can see though as pen testers, as we're thinking like attackers. Now, again, we started to talk about understanding not only the OT assets in the environments like PLCs and HMIs, but how are they related? And the data historians, right? Which assets are they collecting information from? What other data historians are they talking to? Right? What information, right? What are we using that engineering workstation for? Because you might have one engineering workstation that's only responsible, you only use for programming Siemens equipment, and then you have another one that's responsible for programming Rockwell equipment. Or you have two engineering workstations that do both. You look for redundant systems, which are always a good thing because we always plan on the fact that, yeah, a system is just going to, even take cybersecurity out of the equation, right? Take out attacks. Just the fact that equipment can glitch on you, it can crash, it can die. So we want to have redundant systems. But then also understand, server client relationships. This is going to be a big thing that we're going to talk about. Who's controlling what? Which assets are connected? Then we start talking about the whole idea of looking at the process, the tags and the data points, and the information that we're storing not only in the PLCs as it monitors and controls the environment and the process, but all that information is also gathered on the data historians. And that we also see it displayed on HMIs, at least some of the data, not all of it, but some of it, some of the more important pieces of information. So what can we make out of all of this sensitive information? Again, we use it to understand how the environment actually operates. And we'll see some examples. You'll have a couple of lab examples that you'll go through from an attacker perspective to reverse engineer the process to then understand, oh, okay, this is how this PLC operates. This is how the process runs. And oh, this is where I can make a change to make something bad happen, right? To have a negative impact in the environment. And we'll go through, and actually I'm creating a separate kind of like 4-hour like mini course about how PLC programming and logic works. We are going to talk more in depth about how the PLC actually operates as far as bringing in data and processing that and then sending signals out the outputs if we need to, and a short little housekeeping phase as well. So we're going to talk more about that. But it's also good to understand just the basics of how PLCs and controllers are programmed. And then we can understand how safety also comes into play. Because we want to make sure the environment, not only is it a physical safety, we don't want issues that can kill or hurt somebody, but also want to make sure that the equipment doesn't get damaged as well. So we're going to talk a little bit later on about that, but I'm also going to get a mini module that'll go through or go along with the course. And then when you also look at, understanding, right, how does an operator see the environment? This is where we're going to talk about in later sections, especially what if we start making changes in the environment and then we start tripping alerts that an operator needs to respond to? What could we do to understand not only those types of alerts that might come up, but how we could silence those alerts so an operator never sees that anything is wrong in the environment, just like in Stuxnet. Remember, those uranium gas centrifuges were being physically broken down behind the scenes, but if you were sitting in the control room, everything looked perfectly fine. So we're going to have some labs that help us, and we're going to hide what's going on in the background in the real world from the operators sitting in the control room. And part of that is we're going to be disabling any alerts that might come up that would try to get an operator's attention. I want to make sure everything looks perfectly fine. So now that we've spent time talking at a high level about how we're going to go through these different steps of understanding the process, right? What the environment is doing, right? Why does that plant exist? And then looking at the different components, the systems within the environment, right? How they're related and how they control equipment out in the real world, how they're programmed, right? The relationships between those different OT or control system assets. So we're going to look at examples for each of these. So it's just not us talking at a high level. So I think this is, definitely a little bit more interesting. So the first part, remember, we started talking about if we go into a new environment, we have to understand why that environment exists in the first place. Right? What's the purpose of the environment and its main process. Remember, we have that main physical process to do something in the real world. So what was that plant designed to do? Right? Oh, it's a power plant. So it was designed to generate electricity. It's a manufacturing plant that was designed to manufacture pharmaceuticals or baseballs or Barbie dolls. So we have to understand what it's designed to do, because then we can reverse engineer. We can start to take a step back. In that environment, what are those mission critical assets we need to run the environment and to meet the mission of what that environment was designed to do? So we have to make sure the power plant, right, that the turbine is always running. So it's always generating electricity. A manufacturing plant is going to have certain pieces of equipment that it cannot live without. They're mission critical, like the MES, remember the manufacturing execution standard or system, and we'll see some examples of that later on. We start looking at the processes themselves and looking in those systems that are monitoring and controlling the process. What are those critical variables that we're watching and network controlling? So if I have that turbine, right, I want to make sure, well, how fast is the turbine spinning? Because we don't want it to overspin or overclock. Right? We don't want it to get too hot, right? We don't want it to overheat. So those are just some of the things that we're monitoring for from a turbine, watching the vibration levels. When you start to understand if I'm an operator in that environment, and we're going to get into this a lot more detail later on, when do we start being concerned? When do we start throwing alerts? Right? If I'm worried about the turbine overheating, well, what temperatures in this environment? If I'm worried about the turbine going too fast, well, what does that mean? What does that look like in this environment? And then at what point would we shut down, in that case, the turbine, to make sure that the turbine doesn't, in that case, more than likely become damaged? Because that ultimately would be our worst case scenario. So we talk about doing crown jewel analysis. Again, if I have that power plant, we can come back and say, yes, the primary mission of the power plant is to generate electricity, make sure it's safe and it's reliable. And we can also say that, and say if you're in power generation in North America, right, we want to make sure we also adhere to all the NERC regulations, right? So we're compliant. But the primary responsibilities are always safety and the operational availability, right? Make sure the plant stays up, running, and doing what it's supposed to be. In this case, generate electricity. Now that's where we come back and say, to be able to generate electricity, what are the main systems that we need, like turbines and generators, to be able to create electricity? So we would say one of those crown jewels is the turbine, or the whole package that allows that turbine to do what it does, right? So we can say the entire turbine control system. And we do have to be able to monitor and control it, because, yeah, if we had issues, if we lost visibility, if we lost the ability to control the turbine, then it would be a catastrophic impact. What if that turbine became damaged, and that turbine, there's a 3-year waiting list to replace it? You really want your power plant down for 3 years? That would be absolutely catastrophic to the communities that you were actually delivering power to. So that's when we start at that high level, right? Understanding, okay, what systems are in place that are considered mission critical? Those are our crown jewels. Then we can start asking questions about, well, again, what are the details that we're monitoring and controlling around that crown jewel, around, in this case, remember, the turbine control system. Again, we want to make sure that the DCS, which is monitoring and controlling the turbine, right, we're watching for speed. Again, we want to make sure that we're not going too fast. We also want to make sure we're not going too slow, because that could mean that we're not generating electricity as efficiently as possible. But we don't want to go too fast where we get into overclock situation where we could damage the turbine. Same thing, we can watch out for changes in vibration, which would indicate some type of equipment issue or potential upcoming malfunction. The load that's on the turbine itself, right? These are all things that we need to be able to monitor and control. Then we can start asking questions, and this is where we start getting to risk assessments, which we're going to talk on a little bit later on this course, but it's more for other different courses outside of penetration testing. But what are some of the potential threats? What would happen if an attacker was able to, let's say, gain control over the DCS, which was responsible for, in turn, monitoring and controlling the turbine? Could they create that worst case scenario where the turbine does physically break down and you can't replace it for 3 years? Or what's more common? More common is that the IT network that the power plant's connected to becomes compromised with ransomware, and we shut down the plant out of an abundance of caution. Right? That's the most common scenario. But we have to talk about both. And we'll focus most of our time around protecting against the common scenario. But we do, in the back of our mind, always have to keep that worst case scenario also there. And that we're always protecting against it as well. So let's define the process, right? Define the purpose of the environment. So next we're going to talk about, right, how do we start to map the network? How do we start to look at the different types of assets that are in the environment? Of course, when we talk about mapping networks in OT or ICS production environments, we don't want to talk about active scanning. But we will a little bit, because attackers aren't going to hold back typically. But we're going to start with passive reconnaissance, right? Passive sniffing of the network, right? We're just watching network traffic. We're not generating any traffic and putting it out on the network, right? We're not generating packets with a tool like Nmap. We're just watching to see what's going on and what can we learn, right? Start to see the presence of, oh, okay, we have something over here at this IP address and something over here at that IP address. Great. It's a start. And then, oh, are they talking to each other? Are they related in some way, or maybe not? But we have to start building, right, that map of the network to understand how the network itself is built out and how these different assets are related. And if they're not related at all, we also need to know that. We can start looking at, well, what protocols do we see in the environment, right? Because different protocols operate different ways, especially in the OT world. And there's certain pieces of information we can get from protocols like Modbus, and it has some differences with other OT protocols like S7 or DNP3, or maybe like BACnet. So we want to see what's in the environment, how they're talking, right? Read the information, look inside those packets to see what useful information we can use for mapping out the network and determining what relationships we have between assets. And then you can even use that to start to get an idea of the overall architecture of the environment, including potentially, right? We talk about zones and conduits from a 62443 perspective. Or for now, zones are logical ways that we break up assets that have the shared security requirements in an environment. And we'll see some examples. So if it doesn't make sense for right now, don't worry. It's just a logical grouping of equipment. And then we say the conduits, that's the communication we have between those zones. A lot of times you'll see zones implemented as different subnets or VLANs. And so that could make it a little bit easier when they're architected so that the zones have their own separate subnets. Yeah, makes it super easy. So again, one of the ways that we can watch traffic over the network is we can use a tool like Wireshark as a packet sniffer. Or maybe as a pen tester, right, you come into an environment and maybe you don't even need to install Wireshark. Maybe they already have some type of tool already installed, right, that allows you to watch the traffic. Maybe you gain access to, maybe they're actually doing network security monitoring and you can gain access to that platform. I've actually done that before. That's super fun. Remember, most environments aren't doing network security monitoring, but maybe there's some PCAPs laying around, maybe on some engineering workstations that you could start with. Or maybe you could look at, and I've done this in some environments as well, as you can tap a switch. I actually had an environment where I was able to intercept credentials for one of the administrators. In fact, I was the network manager, and intercept his credentials going over the wire, logging into one completely unrelated device, but he reused the same credentials for logging into network switches. And I was able to log into the network switch and then configure basically a span or a mirror port. So I duplicated all the traffic in the switch and had it sent to my machine so I could actually see what was going on. So you want to be able to watch what's going on. But again, if an attacker or a pen tester get in the environment and they have the capabilities, right, they can sit there and watch the environment to learn about it, which of course we don't want them to, but it's definitely one of those options once they are in the environment. Maybe they are worried about if they start scanning, right, they don't want to give away their presence. So they're not going to at least start scanning right away. So here's an example, and we're going to go ahead and jump over to the live Wireshark. And here you can see, I'm going to just make this full screen so it's a lot easier to see. So this is the first PCAP that you can find in the captures file with the course material. So this is the PCAP labeled pentest_001. And so what you can see is this simulates Modbus communication, right? To look at this real quickly, the first three packets are actually the three-way handshake in TCP IP that establishes communication between two hosts, right? So in this case, we can start to see, oh, we're establishing connections between 192.168.1.15, which initiated the connection, which can become important. And then it's connecting to 192.168.1.186. So they established that connection with the SYN-SYNAC ACK process. And then the rest of the traffic that we've captured in the packet is Modbus. Right? If we want to just limit it to Modbus traffic, we can just put in Modbus in the filter bar and just run that. So that just takes out the earlier three-way handshake that we were talking about. So that could become helpful in other types of packet captures that you're reviewing. And we look at this, right, it's a very simple, right, packet capture just to get started, where we can see, right, these two hosts that are communicating to each other, right, over Modbus. Remember, with Wireshark, it has those parsers that it uses to break down, right, the actual data that's being transferred and tries to show us what's going on in quote unquote plain English that we can read. So on the far right hand side, you can see, oh, okay, the first host issues a read coils command, and then what it looks like is that host is going to respond. So I would start to think, oh, okay, so the host at 192.168.1.15 is reading the coils, right, from some type of asset. That's more than likely going to be a PLC. They were reading coils and registers, more than likely that's from a PLC. And then as far as the device doing the reading, it could be an HMI. It could be an engineering workstation. It could be an attacker in the environment with their own workstation. But if we want to actually see what's actually being read, we can open this up and we see. And the really cool thing, there's a lot going on here. And if you've never seen this before, again, it can be a lot. But what Wireshark is showing us, it's showing us the data from the perspective of the OSI layers. or the 7 OSI layers explain how networking and especially with TCP/IP works. And so we can see at the very bottom of the OSI layers, this is the physical layer. So it talks about physical aspects of the network itself. Like, yeah, it's an Ethernet network. And you can start to get really into the details, right? And it even gives us a breakdown of what's in the frame. So we know, okay, yes, this is Modbus traffic. Great. Now, next, when we talk about the data link layer or level layer 2, this is where we see MAC addresses. Because that's where we have the media access control sublayer or the MAC. That's where our MAC addresses come from. Now, the really cool thing with MAC addresses is that the first half of that 48-bit address, which is written in hex, the first half you can look up in a registration table because the manufacturers of these devices, when they create that network interface, they actually literally write the MAC address to that interface. And the first half is associated with the vendor or the manufacturer. So in this case, you can see, okay, the destination of what we're guessing as a PLC that we're talking to, its MAC address starts with 0011 and 00, 0011, 00. If we do a lookup for that, it tells us, oh, that's a Schneider Electric device, right? We can see Schneider Electric here because you can see Wireshark actually does the lookup for us. We don't even have to go to a website to do the lookup. And then we can see the source, right, with a MAC address of 001422 actually resolves to Dell, right? So that probably lends itself to maybe it's some type of engineering workstation. So we already start to get a lot of really good information just from this simple packet capture, right? We probably have a PLC talking with an engineering workstation, or again, maybe the Dell is an attacker laptop. But we also saw it's a Schneider PLC. We know the IP addresses because in this case, right, we're looking at the IP layer, layer 3, what they call the network layer. So we can see the IP addresses. That's the most important part, of course, that comes out of there. And then at the TCP portion of when we talk about the transport layer or layer 4, this is where we see, well, what ports are being used. Or so Modbus, right, the default port is TCP 502. This is where let's say the engineering workstation is connecting to the PLC on TCP 502. Oops. And that the source ports, right, the random high order port that we're coming out of the engineering workstation is 502.01. And then we're not done yet because that's just all the information that's in the header of the packet. Because then we want to look at the actual data to then understand, well, okay, we knew it was this read coils command. Well, what are they trying to read? In this case, what it says is, I want to start reading at coil number 0. Remember, coils and registers are 0 base. So the first coil is 0. And then we can tell it, hey, give me 1 coil, give me 10 coils, give me 100 coils. Or in this case, it says, give me 2. So start at the very first coil and tell me what the values for the first coil and the second coil are. Okay, I know it's really weird if you haven't seen this before, but you'll get used to it with practice. So, okay, we issued a command to read the first 2 coils from that PLC. So if we look at the response, we can jump down to the data in the packet in the response, and we can see, oh, okay, the value for the first coil, oh, it's 1. And the value for the second coil is also 1. Or the 1 typically will indicate some type of on condition. We're looking at maybe some type of like a pump is turned on, a motor is turned on, a valve is open. We see those response. Now we can also look at, if we want to talk about, remember, registers. So coils, remember, it stores binary data, zeros and ones. Registers store data with a value of 0 to 65,535. So in this case, we could look at one of those read register commands and see kind of the same thing. It's saying, hey, start with the first register and give me the value for the first two. That's what that's saying. So, okay, if we look at the response, then we can go back and we can see, okay, the first register has a value of 4,660, and the second register has a value of 22,136. So we're learning all of this just by watching traffic on the network. I don't even have to connect to the PLC and issue the commands if somebody else is doing that for us. But we can use that information to start to at least understand, reverse engineer what's going on in the environment, right? What does that 4660 mean? What does the 22,136 mean? Or if I'm looking at those earlier coils, right? What does this one mean in the first coil? What does this one mean in the second coil? What would happen if I turn these to 0? Now, as an attacker or a pen tester, I don't want to make those changes, because what if that created some type of issue that then the operators would find out, right? That potentially that I'm in the environment. But we need to be able to understand eventually, what do these values mean? So again, we're just getting started with discovery and collection using passive means like looking at packet capture. And here's just the graphical representation or walkthrough of what we were just looking at. All right, as we go through that packet capture, we discover what looks to be, a PLC at 192.168.1.186, and we're querying it from, let's say, in this case, it is an engineering workstation at 192.168.1.15. And that because of the MAC addresses, or we could do that reverse lookup, or in this case, Wireshark does it for us. It does the reverse lookup, and it's going to tell us, oh, hey, that engineering workstation, that's Dell. And for that PLC, oh, that's Schneider Electric. Wow. It's great information to have, whether we're attackers or pen testers, or we're just trying to build out our asset inventory. So we can find some basic pieces of information just by watching network traffic. And we'll see how there's even examples of where we can learn even more, kind of take it to the next level. So there's our Schneider, right? And then there's our Dell. So again, we're just building that map. Again, we're just getting started, starting to get that basic understanding of what's in the environment, right? This is still very much more discovery. We're just finding assets, what IP addresses they're at, maybe what type of asset, right? Who's the vendor, the manufacturer. Now here's another example, and you're actually going to walk through this with the lab. This is actually the second packet capture in the captures directory. I think there's 7 total. Because then you can start to look at this packet, and this is more Modbus traffic. We typically focus on Modbus in this course because it's the most commonly used protocol. And we'll come back in a later workshop and look at other protocols like S7 and DNP3. So let's open up that second pen test capture, or pen test 002 PCAP. Remember, this is in the captures folder that you'll find in the course materials. And again, just a reminder as well, if you have questions as you're going through the content, definitely add them to the comments section under the video and I'll get back to you. But we can go ahead and open up that packet capture because there's a couple of things that we want to look at, right? Because we're starting to build our knowledge, right, as we go along. So that first packet capture, we looked at one host talking to another, right, and looking for the vendors associated with those hosts. In this case, it's a little bit different, though. We actually have more than just to host. And the way the numbers work, it makes it a little bit confusing as well. So we're going to take this time to actually start looking at some of the functionality that Wireshark has. There's a bunch of different options if we look under statistics. So we can look at some of the things like I do typically go to protocol hierarchy first, because if I don't know what's in the packet capture, real quickly you can see it's going to tell us, oh, okay, I see IP version 4 traffic. There's a little UDP traffic, but most of it is TCP traffic. Looks like that UDP traffic that we're seeing is broken up between SNMP, right? Simple Network Management Protocol, especially love to see that in Siemens environments. Network Time Protocol and DNS. You might have an OT or ICS environment that you never see DNS traffic. So that might be suspicious in some OT environments. But most of this packet is going to be Modbus traffic, we can see, right? Basically 94%. But again, it's a quick tool to show us, hey, yeah, here's the different protocols, right? This is what's actually in this packet. Great. We can also look to tools like, okay, show me the conversations. Show me which assets are in this packet capture and who's talking with each. So here's Ethernet addresses. So here's MAC addresses if we wanted to get into those. Or how about, let's look at the IP addresses and show us, okay, who's talking with who, and can see the amount of traffic, right? Very small amounts of traffic, right? This is a very small packet capture. We didn't want to go too crazy. You can even look at different ports for TCP ports or UDP port combinations as well. I'm like, oh, okay, well, that's interesting. Not too useful in this case, but you get kind of understanding again of what's there. I really like just endpoints to tell me, hey, how many assets are we seeing? So in this case, it says, hey, we're seeing 9 unique MAC addresses in this environment. Okay, great. And we see 9 regular IP4, IPv4 addresses. You see 1.100, 101, 110, 111, 112, 113, 114, 150, 200, right? So we've done discovery. We have, let's say, 10 IP addresses. Oh, no, 9, it tells us, in the environment. But then we have to start to learn, well, what are these? Well, what can that TCP and the UDP traffic tell us when we start examining what's actually in here? Because we can start to look at the Modbus traffic like we were in the previous. And then we can scroll down and we see, oh, there's all this other traffic as well. Right? So we can see, oh, someone's doing a DNS lookup. So from 192.168.1.100, it thinks at least that 1.200 is a DNS server. And we can see it's actually asking for the IP address for a host at plc1.local. So now we're starting to get an idea of, okay, the naming convention in the environment. And, it's looking for PLC1. And if there was a response, which we don't see, but that would say, okay, there's this PLC over here called PLC1 at this IP address. We can see some network time traffic that we could start to get an idea of, are these servers, are these types of assets trying to update their clocks? And then we can also see SNMP. So this host at 1.100 seems to be polling .110, .111, .112 on SNMP. Is trying to figure out what's going on with those hosts. So is that some type of monitoring solution in the environment, or is that an attacker? So there's a lot of interesting traffic. Again, it starts to give us, what are these IP addresses, right? We need to start to understand, right? What are they in the environment? How are they related? Now, real quickly, as we wind down some of these packet capture reviews with Wireshark, you have to remember Wireshark does have its limitations. Or Wireshark is a GUI, right? And so it can start struggling even on fairly decent machines when a packet capture goes over a gigabyte. Right? So that's where when you start talking about larger PCAP files and dissecting those, you're usually going to a non-GUI tool. Like so T-Shark is the terminal version of Wireshark, or you might have a platform like Zeek where you can dissect different packet captures, almost from that intrusion detection analyst perspective. Right. So just keep that in mind. That just doesn't necessarily come into play for this course. And I don't think I've had, like super massive packet captures in OT environments. But if you are recording over a significant amount, period of time, just make sure you can break them up so that way they're not too large and easier to digest. So if you were acting as a pen tester or an attacker and you went into an environment and let's say you have access to an engineering workstation and you wanted to install Wireshark or T-Shark on it, remember, just if you're going through the process of installing any application on a host, there's a chance if that organization is monitoring those hosts and host activity, they should detect when a piece of software is actually installed. Again, they have to be doing the monitoring. Most environments aren't, so they probably not. What you might actually come across is somebody actually has a whitelist or a blacklist set up. So they're not going to they actually have it so the system's configured not to allow you to install anything that's not essentially on this safe list to be installed. Or maybe you do get Wireshark installed, but there is a blacklist or whitelist preventing you from running it. So that's more than more likely what you're going to come across rather than somebody actually detecting that you're installing Wireshark in the first place. But again, just a couple things to keep in mind about using Wireshark in OT or ICS environments as a penetration tester. As I mentioned earlier, we do talk about other protocols. Now, in this course, we're going to just lightly touch on other protocols like S7, right, for Siemens, or DMP3, which we see in power generation and in transmission, right? Ethernet IP, which we see especially with SIP, Ethernet IP for Rockwell assets. Those are all TCP base. Now, BACnet is a little bit of a different beast, right? Because it's for building automation controls, right? Elevators and door badge systems and HVAC systems, and it's UDP based. So we'll see an example later on. So we're definitely going to touch on these, even though we don't go into too much depth on in this course, but that's going to be later workshops, right? That'll go into each of those more in depth. So. But of course, these are just the more the common ones that you see, or at least you get exposed to. There are a lot of other OT or ICS protocols out there, even the ones that environments write on their own. So they've written their own custom OT protocols, like Disney World. You go to Disney World, they write the language for each of the rides and how each of those rides operates. Because each of those rides is just one big control system network, which is kind of cool when you think about it. All right. So that takes us to lab 6.1. So you're going to go back over the different packet captures we were looking at, right? Trying to dissect them and understand what assets in their environment and then start understanding the relationships between those assets. Now, also, you're going to dive right into another lab. This is where we're going to get the Labshock environment up and running on your machine. So remember, Labshock, which was created by Zachar Bernhardt, right? It's a great, awesome platform, which is built in Docker. So it's very low on resources, right? It's free and open source for personal use. I should say it's free. I don't know. I shouldn't say it's open source, but it's free for personal use. He actually did provide a license for me doing training, which I really appreciated. You can see his LinkedIn page, his YouTube page there as well, and then you can just find the GitHub download for Labshock if you Google for it. But we'll definitely be using that in the course, and we'll be doing a walkthrough as well. And we've already started to see it, right, with the HMI and showing the oil fields and how we start to manipulate the environment. So this is where you're going to start building that out for your own lab purposes. Now, one thing to also keep in mind, one way we can find assets in the environment. And again, this goes whether you're doing a penetration test and you're trying to go through discovery and collection, or what if you're just trying to build out your asset register. You can actually start to examine the different equipment you have in the environment, because you can look at a firewall, right? A firewall is going to show you traffic flowing between hosts and what ports, what protocols they're using. You can use that to start building a network map, at least from what the firewall can see, right? Same thing with all the switches in the environment. Well, what if I log into a switch and look at the ARP cache on that switch? I can see which hosts are connected through that switch, right? Which ones are talking. Again, we can take those MAC addresses and do a reverse lookup to find the vendors, the manufacturers of that equipment, routers, proxy servers, remote access solutions, right? Which also tie in usually with jump hosts, right? Those usually, right? They talk with other systems, unidirectional gateways, data diodes, all of the equipment we have from a networking perspective in the environment, no matter what it is, you can log in if you have access, right, as the operator in the environment, or as a penetration tester if you're able to gain access. And then you can look for clues on those assets, like a switch, on what's actually in the environment. So here's an example. What if we do log in? Let's say this is a Cisco switch, right? Which is just see Cisco everywhere, in especially larger OT ICS environments. You're in that plant, you have access to that Cisco switch. Maybe they had really easy to guess default credentials to log in. And you can log in, and then you actually can run commands like show IP ARP. In this case, the switch has multiple VLANs, or if you want, usually those kind of map out to subnets if you want. Or again, in OT, a lot of times these map out to zones, right? Our collection of assets based off of your security requirements. Now, there's not always a one-to-one relationship, I should say, but yeah, kind of mostly, I think just for administration purposes and keep things easy, yeah, a VLAN usually equals a zone and usually equals a subnet. Again, not always, but a lot of the times it can. So I can say, hey, show me all of the known IP addresses and the MAC addresses for those IP addresses associated with VLAN number 10. And then boom, we get this list back. So you can see, hey, we see IP addresses at 10.10 and 10.11, 10.12, 10.13, 14, 20, 21, 22. And you see that's all fairly recent communication, right? So they're fairly, talkative, assets on the network. And then we can see the MAC addresses. And you can see just by the first half, right? Looks like the first 5 assets are from the same manufacturer and the last 3 are from the same manufacturer. Now, in this case, we're not using Wireshark to look at the information, so it's not doing the lookup for us. But if we want, we can go and use a lookup like the Wireshark lookup that they have online. And this is how I find it. So I just go to Google, do Wireshark MAC lookup, or you can do something like ARP lookup. You get the idea. So Wireshark MAC lookup, right? It's going to pull up and you can see I've been there a million times, the OIU, the OUI, so we'll get it right, lookup tool. Right? So the OUI sort of stands for organizationally unique identifiers. Remember this process that if you manufacture a network interface, you have to hard code a MAC address on it. And so that has to be registered. So let's add the MAC address, the first half, right? That's the only part that matters. So it goes 00 and then 1B, 1B. And you can see it comes up. Oh, well, look. It says, okay, yeah, this is Siemens. So we know, that's a Siemens piece of equipment. Now, we don't know what type of equipment necessarily, but we know at least for now it's Siemens. We know the manufacturer. We know the vendor, which is a great starting point. Right? So it's a great tool. It's a great technique to be able to do that MAC reverse lookup to start to map out what's in the environment. And that's what you're going to be walking through in Lab 6.3. So I actually created a simulated virtual, Cisco firewall. And then you're going to be able to log in as if it's a real Cisco firewall and run a couple of different commands to start to gather information about what's in the environment from that discovery and collection perspective. So hopefully you'll have a lot of fun with that. I had a lot of fun putting that together. So, but again, it's just another example of how you can log into different network devices like switches or firewalls to find out more information about what's in the environment. So once you're done with the lab, the next thing we're going to start looking at is active scanning. Remember, I have to put the disclaimer that I can never suggest anybody does active scanning where we create network packets and put them out on the wire and send them towards targets. Or I can never suggest you do active scanning in a production environment. If you do, that's between you and your client. Can it be done and not cause any issues? Sure, it happens, but there's also that chance that something bad does happen, like bringing down a plant. And yes, it does happen. So remember, we use active techniques very sparingly. And again, I can never suggest you use it in production. But think if we're doing a pen test, and let's say in a test environment, and I can generate packets using a tool like Nmap, right? I'm sending additional packets out to different IP addresses, not only to see is there something at that IP address, right? But what ports are open on that IP address? And then we can look at, okay, well, we found a live host at this IP address and we found these open ports. Well, what's running on those ports, right? What applications, what protocols, what services? And then we can find out additional information about those applications or those protocols. What type of protocol is it, or what service is it? What application? What version? What vendor? We can use that information to find, right, are there vulnerabilities on that target asset? So we can use tools like Nmap to be able to find those systems, those open ports. Ultimately, right, not only the ultimate port, but the vulnerabilities associated with those assets and what's running on those assets, what's exposed. So here I can open up a command prompt on my machine. And if I want to run Nmap, we're going to do a couple of different scans just to give you an idea. Right? I can go ahead and do an Nmap against my local subnet where I actually have a test environment where I have a click PLC set up. And so I can say, okay, I'm going to run Nmap against 192.168.100.0/24, right? That represents that entire Class C subnet. So it can have 254 hosts on this network. Now, the only one that's on it right now is that click PLC. So if I want, I can say, okay, do something like, oh, just do a ping sweep. So just tell me when the asset is found, right? Or it'll tell me if there's, any assets on that local subnet. And you can see it comes back with two different ones. So we can see there's one at 192.168.100.200, and that's the MAC address associated with that host, right? We take that first half of the MAC address, 00D07C, just like we were looking at. We can look that up to see, oh, that's JTech Electronics. JTech is the company that ultimately manufactures the Click PLC. Great, awesome. And then we can also see, oh, there's another host on that subnet, which is my host, right? The Windows machine running at 192.168.100.99. Right? So, okay, we know there's something running at this IP address of 192.168.100.200, and we know it's made by JTech. So next we'll want to look at, well, what ports are open on that system? So we're going to type in Nmap 192.168.100.200. Now in this case, I know what it is and we're kind of cheating, but if I didn't know exactly what it was, let's say we want to scan all 65,500 TCP IP ports. So I'm going to go ahead and do nmap 182.168.100.200, and I'm going to do -p-, which is just saying scan for all 65,535 TCP ports. Like, okay, let's run those. So it doesn't take long before the Nmap scan completes, and you can see it found one open port, TCP 502, which is the default port that we use for Modbus. So we're already starting to suspect, oh, okay, well, this is a host running Modbus, could be a PLC then. So we can try to run an additional Nmap scan using the service scan. And what that does, and we're going to specify port 502, that is, once it finds an open port, it's going to do additional checks to see if it can tell, okay, is this Modbus? If it is Modbus, what other pieces of information about that host can I find out? Now, what we're going to see is that the way that Click PLCs operate is you don't really get a ton of information back. We can see it's definitely Modbus over TCP. Again, we still know, okay, it's a JTAG PLC. And then, okay, well, let's see if we can also run a Nmap scripting engine or NSE script. This one's going to be called Modbus-Discover. So we know Modbus is there, so it's going to issue some additional commands to see, can it pull some additional information to tell us, well, who's the vendor, what's the make, what's the model of the PLC. Now, the way that the Click PLCs respond, they don't actually give up that information. So they're a little bit different than a lot of other Modbus PLC hosts that are out there. So we don't see anything else like we would if like we've used the Modbus Swiss Army knife tool, right, in the past to pull that information about the vendor and the make and the manufacturer of the PLC. So unfortunately, the Click PLCs don't give up that information. So I guess unfortunately from the pen tester or attacker perspective, but fortunately from a cybersecurity perspective, even though, okay, we know, yes, there's a Modbus PLC sitting there and that we can connect to it using the Swiss Army knife. Because we can go ahead, let's type in the IP address, and then boom, you can see where we can connect. And then we can say, oh, okay, well, tell me how many coils and how many registers are on the PLC to start with. So we see, oh, there's 288 coils. And then, oh, there's at least 1,000 registers. The tool right now only checks for 1,000 because typically a lot of environments, you won't see more than that. But in this case, yeah, we see more than 1,000 registers. You can see, again, if we do try to read the device identity, it just comes back and says, sorry, there's nothing there for read. Because again, the Click PLC doesn't respond like a lot of other Modbus hosts. But that's a little introduction, right, to how we can use Nmap to find Modbus hosts, to find PLCs, and then we could use another tool like the Swiss Army knife to go ahead and connect and be able to do things like, well, why don't I read, the first 50 coils in memory to see what potentially could be happening? Could I make changes, right? How does that control the process? What changes could I make to make changes to the process out in the real world? That's why we're going through all of these different steps. So that's active scanning with Nmap. If you do want to learn more about Nmap, I know we're not getting into the weeds in this course, but I have an entire dedicated class on Nmap for OT or ICS environments. And you can see there's 2 parts on YouTube. So definitely check those out. I think it's about 3.5 hours across those parts. So it talks about everything from running Nmap and OT, how it tests, how packets actually work between sending and receiving data in not only TCP environments, but those using UDP. And there's big differences between the two and how they operate. So there's a lot of details that you want to be aware of as a pen tester. We're just not diving into them in this course, but you can go and grab that essentially separate course on my YouTube channel. And as we've mentioned more than a few times, and I'm sure you'll hear me mention it again, right? We can never suggest that anybody does active testing inside a production environment. I've shared a couple of stories, right? When I was at DEF CON earlier this year, and I had two different people working in two completely different power plants had mentioned, right, that there were outages caused by people running tools like Nmap or Nessus. And then there was a podcast I was listening to by two gentlemen that were doing pen testing, active pen testing in a power plant using Nmap, and brought the plant down. And that was just those three instances. Or my friend from Amsterdam that talked about the manufacturing environment that he works in, and somebody blew up their PLCs using Nessus. So remember, we can just, there's too much of a chance when we start talking about doing active scanning in production environments where safety and availability issues exist. And so it's mostly, yes, about safety, right? Making sure everybody stays safe. Not only that, but what if we cause an issue that did damage to the plant, even significant damage to the plant, where the plant couldn't operate for days or weeks or potentially years? It's just not worth it. Now, there's also this idea that, and you hear this from pen testers in both IT and OT. Well, what if the defenders detect me? Well, remember that very few OT environments are actually doing network security monitoring. So if we say 5% of environments are doing network security monitoring, and I still always say about half of those are not doing a very good job, then A, they're not going to detect you. But B, let's say they do have a SOC. Let's say they are doing network security monitoring. Let them find you. At least have them try. Because you want them to detect you, right? You're not an attacker. You don't need to be super sneaky, right? That's more of a red team exercise where you're trying to be super sneaky over a longer period of time. And in a pen test environment, you might have 40, maybe 80 hours to do your testing. You don't have the time to be quiet and sneaky and worry about whether they detect you or not. You actually want to see them detecting you, right? That actually shows that they're doing their job. And if they don't, you can work with the client to help them understand, hey, these are all the different types of tactics and techniques or the tools we were using in the environment. These are what the different steps we were making in the OT network, and your team didn't see me. So let me help you help them in looking at, okay, how can we bolster our monitoring defenses? Because there's obviously a huge gap in most environments there. So just something to be aware of as we move forward. But we'll talk about it again. So we talk about, well, what other choices do we have for scanning in OT environments? If we're doing this in a test environment, or your client says, go ahead and do this in production. What other options do we have? And I did want to go down this path because I think there's some interesting points that people should be aware of in this environment or this world now of all things Gen AI. Because as we start to look at attackers and incidents that have happened over the years, when especially I think back to the outages, the blackouts in 2015 and 2016, where the Russians turned out the power in Ukraine. Middle of winter, hundreds of thousands of people impacted each time. In those cases, they created specific ICS pieces of malware to go in and cause those blackouts. So they had to spend millions of dollars, spend months and months to develop those capabilities before they could deploy them and eventually create a blackout. If you fast forward to 2022, where there was a blackout in the Ukraine, there was no special ICS malware. They didn't spend millions of dollars and they didn't spend months and months and months developing some type of special capability. They just used living off the land techniques. They just moved essentially from Windows machine to Windows machine. They got into the IT environment. They found what was described as a bridge between IT and OT. I don't think they've still publicly disclosed what that is. So they moved from IT into OT. And then they're sitting on the Windows machines on the OT network and found the web interface for their SCADA manager where they could log in with easy to guess credentials, find the interface, the HMI that controlled the breakers for the power. And they just flipped the breakers to turn off the power, and then they wiped all of the machines as they always do. So we've seen how Sandworm has evolved their tactics and their techniques over time to where, again, they're not wasting time. They're not wasting money on developing ICS capabilities, right? In specific pieces of malware. There's no need to. We can use living off the land. Remember, living off the land just means we're using the tools and the commands that are already in the environment for us to use. We're not installing anything for a defender potentially defined. So I do like to create, and you hear me talk about this a lot, right? I like to create tools using tools like ChatGPT and Gemini. And you can see here we can create a really simple port scanner. And it's going to look for a handful of IP or usually what we consider IT ports. Like you can see 21 for FTP, right? 22 for SSH, right? 23 FTP, 80, 443 for web interfaces, which we can also see those in OT networks, right? And a few others. And then we can also see some OT or ICS specific protocols like 102 for S7, right? From Siemens devices, or 502 for Modbus, et cetera, et cetera. So let's go ahead and create this, and we'll go ahead and run it. So here I'm logged into ChatGPT, or actually I'm just on the ChatGPT page. I'm not logged in. We're doing this for free, right? So anybody can do this. So I'm going to take the text we had earlier. I'm just going to submit that. Say, hey, create a Python script that's going to act as a port scanner to look for a handful of common IT protocols and a handful of OT protocols. And it says, okay, here you go. Here's your script. It'll even come back and say, okay, here's what it's going to do. It even shows us what it's going to look like. It talks about some notes as far as, how the timeout works, and it's basically saying, okay, it's not going to be super fast. We can make changes if you want to increase performance. We're not going to worry about that at this point. But I can just take this code, right, and I can save it out and run it. So I've saved it out to my scripts folder, and then I just called it port scan. So I can run the port scan Python script. And you see, if I could just run it by itself, the first thing it's going to do is say, oh, well, what's the IP address or the subnet mask? Well, let's go ahead and run it against one of the earlier hosts that we were looking at. So remember, we have 192.168.100.200 was the IP address of the PLC that we found earlier. And after about, 15, 20 seconds, it actually comes back, right? It scanned each of those ports on the IP address, and then you can see it comes back and says, oh, hey, we found TCP 502 was open on 192.168.100.200. Awesome. I have a port scanner. Now, as a pen tester or more as an attacker, the problem with this is to be able to run that script on, let's say, a Windows host inside the OT environment that I'm able to gain access to. More than likely, it doesn't have Python installed. More than likely. I hope not. It shouldn't for security purposes, right? Sometimes it does. But if I have to install Python, that should tip off the defenders that were in the environment. So instead of using a tool like Python that doesn't run natively on Windows, well, let's use a tool that does run natively on Windows, because we can convert this over to PowerShell really quickly, just going back to ChatGPT. So we're going to go back to ChatGPT. We're just going to type in, right, convert this Python script to PowerShell. Hit enter, let it do its thing. Right? It's going to take the Python script, convert it over to PowerShell. We can copy that code. Of course, it's going to tell us, okay, this is what it does. This is how it works, just like we saw previously. And so now I can go ahead and save that out as a PowerShell script and run that. But remember, PowerShell is already built into Windows, so I don't have to install anything else for it to run. So now we can open up our terminal or command prompt, and I'm going to go ahead and remember, I don't have to run Python any longer. I'm just going to launch into PowerShell. I'm going to just go ahead and run the port scanner. And just like before, it's going to say, oh, okay, hey, what IP address do you want us to scan? 192.168.100.200. Let's go ahead and scan that. And you can see, while it looks a little bit different, that, yeah, we found out that on 192.168.100.200, yeah, we have TCP 502 for Modbus open. Great. So again, it gives you an idea how you can use tools like ChatGPT or Gemini or other Gen AI platforms to create simple security tools like a port scanner. And not only you can create a port scanner in Python, which would require us to install Python on a target system, but what about converting that over to PowerShell? Because we're seeing attackers, right, moving more and more to using living off the land techniques. They're using what's built into the system. They're not installing new pieces of software. So it's important to understand how living off the land works. And here we've done it using PowerShell. So one of the most commonly asked questions I get when we talk about using these different types of tools, because sometimes you'll create these scanners and they'll sit there and you'll wait, right? We're using editing to make it look like it goes super fast during the video, but sometimes you might wait minutes or potentially hours for results to come back. So there's always a question of like, well, how the heck do I know when the tool is actually working? Well, one way, remember, in this case, we're generating active packets being sent out on the network. So we can use a packet sniffer like Wireshark. So let's open up Wireshark and then we'll run our tool and we'll actually see the activity created by the tool. And so we're going to go ahead and start Wireshark. I'm going to go ahead and use that on the local default Wi-Fi connection. And then what I'm going to do is I'm going to come back over here, right? We see some traffic that's being generated. I'm going to come back over and then I'm going to go ahead and run the port scanner. And then just as let's go ahead and run it against 10.2.1.0/24. So that's the main home network that I have a bunch of hosts on. And sure, we see some traffic and you can see, okay, it's like ding, ding. But once I go ahead and run the command, now we can start to see all the traffic that's being generated by the actual tool. And then you can even start to see as we get some results. So the tool actually, first thing it hit was my Wi-Fi router, right, at 10.2.1.1. And it says, hey, you got ports 21, 22, and 443 open, right? And those are usually expected on those types of devices, right? FTP, SSH, 443, or for the web interface that you can log into and make changes. And that's one way we can start to understand not only is the tool doing anything at all, but even more importantly, right, how does the tool operate? This becomes even more important in OT or ICS environments when you want to limit the types of traffic. Maybe the client is going to allow for maybe ARP traffic, maybe ICMP traffic, because those types of traffic do typically now exist on OT environments. So it's not out of the ordinary to see those, and it's not out of the ordinary to see them not crashing systems. But then at the same time, we don't want to do full port scans. But it gives you an idea. Again, if you want to understand not only is the tool working at all, but what's it actually doing on the network? Yeah, spin up a packet sniffer like Wireshark. Have it running while you run the tool, and then you can take the time to look and see what's actually going on. Now, there are other tools out there, and I find it interesting because most of the tools we have for OT or ICS pen testing are also tools that you might see technicians using out in the field, but they're literally 10 plus years old. So they run on older systems. And honestly, there's not a lot of great functionality in them. And some of these vendors still want to charge you $100 to use them, which I just find absolutely ridiculous now in this time and age. So when I see these types of tools, this is great. And this was great 10, 20 years ago. But now I can use Gen AI to write something very similar. Like PLC scan, right, is one of those very common old school utilities. And they had PLC scan, I think version 2. It's one of those that it runs on an older version, right? Version 2 of Python. So if you had let's say a new Kali Linux box and you downloaded PLC scan and tried to run it, it wouldn't work. But you can take that script since it's open source and you can put into ChatGPT and just say, hey, convert this over so it runs on Python version 3. And that's what you actually see that I did here, and actually ran it and then ran it in the test environment to see that it actually works. I can't share the script. I don't know if I'm going to be violating anybody's licensing agreements, but you can do the same thing. There's nothing to stop you. Or you literally can just say, oh, here's let's say the 10 things that this tool does. You can just ask Gen AI to say, build a tool that does these 10 things. And that you can create that tool. Again, at least for personal use. And double check. Again, you don't want to violate any licensing agreements. But again, that's a lot of these old tools, either they're crazy expensive for what they do in this day and time, right? And I get that 10, 20 years ago, there weren't tools out there to do things like connect to a PLC and read all the data points, right? All the coils and registers from memory. I get that. But it's 2025 going to 2026, right? Times are changing. I don't need to spend $100 for one of those tools. I can just use a free ChatGPT account to create the same thing. So in Lab 6.4, this is where you're actually going to go back and work with Labshock and do active scanning. And so Labshock not only has its own version of Kali Linux machine built into it, but it also has a web interface that allows you to use tools like Nmap to build in. And then you can look at other tools like Buspone is an interesting one that has come up once or twice that people have mentioned, and it acts as another web interface. I'm not a big fan of the web interface. It's kind of like that web shell that an attacker might drop on your box. But some people tend to like them, so we definitely want to include it. So it'll definitely be something for you to experiment with and determine, hey, is it something that you like, or would you prefer working with a command line utility? Again, for me, yeah, I'm just more of a command line person. But again, just personal preference. So now that we've started to find the different hosts on the network, and not only the hosts, but the open ports and what's running on those ports, now we want to say, well, how are these different assets connected? Like, okay, I have a PLC over here. Oh, I have an HMI over here. Are they connected? Is there a relationship between the two or not? Right? That's what we want to start looking at next. So we start looking at, well, how do we identify these different assets and how they're connected? right? Well, we can look for things like, communication between those hosts. So if we're able to watch for network traffic, or we have PCAPs for the environment that maybe a client can provide for us, we can use that to, again, start understanding the environment, those assets, how they communicate, what they're actually saying. Remember, the nice thing in OT environments is that most network traffic isn't encrypted. So we can see the information being sent between those different hosts. So if you have a HMI that's sending commands to a PLC, you're going to see what those commands actually are. So there's a lot of common relationships, or I should say, there's some common control relationships that you're going to see over and over in OT environments. I think the most common is, we're going to have a PLC that controls equipment, right? It controls that process out in the real world. The PLC itself, is interacted with by that HMI, the human machine interface, right? The GUI that we give the operator. So the operator can see, hey, what's going on out there in the real world with the process. And if we need to, we can make changes using the HMI. But remember, all we're doing when we say we're making changes through the HMI, what we're really doing is we're just updating data in the memory of the PLC. That's what's actually making the changes in the control of the process in the real world. Now we can also see we might have a PLC, and what if we have a technician that needs to interact with that PLC? Maybe they want to upgrade firmware, or they want to make a change to programming logic. Then, they're going to hook up their engineering workstation to the PLC, either directly using a cable like RS232 cable, or they're going to do it over the network. If we're going to allow them, remember, we're going to put that PLC into remote program mode with the key switch. Again, from a security perspective, we want to force everybody to use cables to connect to the PLCs to make those changes. But I get it's inconvenient, it takes time, might not even be an option. Maybe the person isn't even on site, let alone maybe that PLC is in a dangerous part of the plant. And we don't want to put somebody at risk. I get that. So it's not just as easy as, well, we're not going to allow it, right? We have to consider allowing remote programming of PLCs. We just have to understand there is risk there, and how do we address that risk? Also, remember that all of the systems in the environment could be sending, logging data or telemetry data to the data historian. So we have another relationship where we have assets like PLCs sending data to the historian. And so there's these main components that we're going to see over and over and over again. And these are just some of the more common, like you might see in a manufacturing plant. We haven't even started to talk about how about a DCS, like in a power plant or petrochemical facility. Or we have that process, the equipment that we're controlling out in the real world. That PLC that I always see as kind of center to everything, at least in this scenario. And that it can log or send data to the historian. It can be connected to, by an engineering workstation to do things like upgrade firmware or make changes to programming logic. And then we can use as operators the HMI to see, hey, what's going on in the memory of the PLC? Because that shows us what's going on in the process in the real world. And we can also make changes to the memory in the PLC to make changes that are reflected in the real world. We need to start being able to stitch these things together to understand. Remember, we're reverse engineering what's going on in the environment so we can ultimately understand what changes can we make as a pen tester, or really, remember, as an attacker, to have an impact in the environment. Now we can talk about, well, how do we collect and interpret process data? And so we're going to talk a little bit about it here, and we're going to come back and talk about this in other sections as well in the course. But for now, we start talk about, well, how can we find, what are some of the ways that we can use to find more information about things like these relationships that we want to map out? And we've already started to see in earlier sections in the course, right? If I find an HMI, or what if there's just screenshots of an HMI actually that are saved like in a bunch of program files on an engineering workstation or an operator workstation? We can use those to help understand the process and the environment, right? We get that literal picture of what is going on in the environment. Or there are some ways that we want to look to see, well, what's the operational mode of that PLC? Remember, is it run mode? Is it a remote program? Because that's where, again, we're going to spend a lot of time around operational modes. Again, I think when you first hear about it, it doesn't sound like a big to-do. But when you think about it, if I can understand the operational mode of what your PLC is currently doing, especially if, let's just say, it's doing what it's supposed to be and it's running perfectly fine. Well, what if I have the ability to just tell it to stop all of a sudden? Stop doing what you're doing. Like, oh, well, that PLC, right, it's controlling the process in the real world. And then if it all of a sudden just disappears, you no longer have any control, right, of that process. There's nothing to tell the process what to do from that point on. That's one of the easiest ways to have an impact in the environment. So that's why we're going to come back and talk about it more than once. All right, we can read any files that are related to the project, right? Whether it's HMI screenshots, whether it's the PLC programming itself. Well, if we have access to the historian where we can find telemetry data, we can use that information to understand different aspects of, what's going on in the environment over time and looking for those differences. We'll have some labs where you'll actually be able to look at different examples of watching an environment, then watching its variables change over time, and then deciphering that to understand, oh, this is what it means and how this process works out in the real world. Of course, if we find network maps, engineering, network diagrams, right, those can give us lots of basic information about what assets are in the environment, IP addresses, communication between those assets, helping us understand those relationships. Of course, here's an example of a very fancy HMI screenshot, right? They do not all look like this, right? But I wanted to include this because this is definitely one of the nicer ones I've seen. You can tell, right? And there's a lot of great platforms now for creating HMIs, so you can make them super, super pretty. As long as there's no performance issue with having like the super, glassy graphics, great, go for it. But typically, right, I still look like this. And they're functional, right? Shows us the environment, shows us the process, and we can look at it from a glance to understand what's going on in the environment and if we need to make any changes. And we have the options to do that if we need to. Perfect, right? That's all we need. Again, as long as it's not interfering with performance, sure, you can have a nice fancy HMI like this one if you want. But yeah, these work too. So that's some more of the kind of collection and discovery that you're going to go through in the Labshock environment, right? What can you do with that HMI? How are you starting to use it to map the environment, to reverse engineer the process? So again, there's a lot of fun. At least I know I have a ton of fun with Labshock, and I think everybody that first starts to play with it really has a lot of fun with it. It is a great, just really cool learning environment that Zach R had put together. So I'm really thankful that he did that. So last but not least, again, ultimately, why we're doing all of this is so we can reverse engineer to understand what's going on out in the real world and how it's being monitored and how it's being controlled. Because remember, as attackers or pen testers, we have the evil thinking cap on and we're trying to find ways that we can have an impact into that process. Remember, a negative impact to make the bad things happen. Because then we can explain to the client, these are the bad things we can make happen. So if we can make these happen, the attacker can make these happen. And more importantly, well, these are the steps you need to take to prevent these bad things from happening, right? These are the security and controls that you can put in place. And so ultimately, again, everything we're talking about here is being able to map out the process, right? What's happening in this plant in the real world. And a lot of that's kind of what we're building up through the rest of this course to ultimately get to that very last module where we talk about, okay, now that we've gone through all the steps to understand and map out the environment and reverse engineer it, to understand the process and how it operates, how do we have an impact? And that's what we're building up to. Now, while we made it to the last part of this section, there's a lot more to come on discovery and collection. So I've actually broken that entire big part into 2 videos. So we're going to have part 6, which we just went through, and then next we're going to have part 7. So again, thanks for watching this part, and then I'm going to see you in the next